process because that's like late.
Mhm.
But for both of the initial, is this initial like equation set up correctly where it's like the mass of A plus the initial velocity of A?
Yeah.
But for both their initial velocities, it's 0.
Right.
Could you group them together as mass 1 and mass 2 together?
So they're two separate. They're in the same system, but they're two separate objects. So you wouldn't actually mass them together because they're not moving. Yeah, they're not moving together, right? But since their initial velocity is 0, then that's good. Yeah, the first part of that will be 0. Do you have a follow-up question?
Yes,
or?
I'm wondering how. Yeah, great. Yeah, I'm wondering how to then solve for the velocities. Is that possible?
The
Yeah.
entire left side would be 0.
Okay, do you guys have any other ideas of concepts that you've learned before that you could use? No, not kinematics. Well, did you do the first portion?
Could you just say that one is like the opposite side?
Why do you think that?
Because like the forces, they like exert the same force on each other.
Yeah.
So I think it would just be like the same magnitude, but like the different side.
Right, right. Yeah, that's correct.
Okay.
Does that make sense?
So like one pushes on.
Yeah, exactly. So if they push on each other, one is going to go in one direction and then the other is going to go in the other direction. So you don't have to solve using kinematics, but using Newton's laws. Yeah. Does that make sense, guys? Yeah. Do you guys have any questions or anything?
In lecture, for this example, he used just momentum. Yeah, but why didn't he? Or is it momentum?
Yeah, that's momentum.
Okay, so to solve it,
We're wondering about
does this have both kinetic and potential energy?
Yeah, so initially, does it have kinetic and potential energy? Yeah, so it just has potential at first, but to solve this particular problem, I think you just want to look at it from a more general perspective and using Newton's laws. So with that in mind, how do you think that would affect the velocities of the two blocks?
momentum. Yeah. And it's because that the relationship between force directly relates to that
Force on the big block.
one
The big
small
block
object
will exert a force on the small block.
Right. Yeah, that's exactly right. So you guys do have the correct answer, but you're just like struggling with your reasosoning?
Yeah.
Okay.
So like, so if they both exert the same force,
I understand like what you're saying about
Exactly.
but I don't understand like how that translates to
this
like,
would move. So basically, this is bigger.
Oh,
because this would
okay.
move the positive direction.
So,
the block.
What is bigger?
have you guys talked
Well,
about how a force
because they have the
is
same
actually the
for-
change
or
in momentum of a
A
change in
is
time?
Bigger because this is moving
By
in this
chance?
direction.
I don't
Yeah.
remember
This is
it.
moving.
Exactly.
Okay.
So I don't
That's
think
the
so.
reasoning. Right?
Yes.
Okay.
So actually,
Does that
the
make sense?
force on an
It's
object
because block
is actually equal to its change in momentum
Yeah,
over the
exactly.
change in time. So you can think of
So we
they
don't
have the
really
same
need any,
force but in opposite
No, you don't need
directions.
equations. You just
But
need to
no, the
know
same change in momentum,
conceptually
but the-
that this block
the
is moving
momentum will
forward in the
be
positive
essentially
x
the opposite
direction
sides.
because of the force
So
that
it's
this
when you
block
add
is
the two
exerting
momentum
on the
together,
smaller block.
it'll still stay.
And likewise,
Yeah, in
it's
this case,
exerting a
it'll
force
stay at zero.
backwards on the bigger
Okay,
block.
and so
So that would be moving in the negative
and
direction.
that's going to be true with their initial state and their final state.
Mm.
So this is just like that initial.
How you guys doing? Do you have any questions or anything?
I think we're doing okay.
You're good? Okay.
I think it's just like M1, and then VX1.
Yeah, I know what it is.
How you guys doing? Good? Do you have any questions?
We just finished the first one.
Okay,
Alright, look at the second.
Could you explain the first one to me?
I put E because do we assume that there's no friction? Like
Yeah.
even the smallest amount, like it'll still move back very slightly, like the large one. Are we
Yeah,
assuming it's negative?
there's no friction.
Okay, so then, or I just wrote out the potential energy equation, and then if or moment.
It's okay.
And then if MB is like much larger than MA,
Right.
then like this one has to be much larger to counteract it.
Okay.
So it's gonna go first of all it's gonna go like that way, and then this one's gonna push back in the opposite direction, just like less in the negative.
Okay. Yeah. That's good. How much time is on?
It's 6:06. Yeah. Yeah. It's okay, you're more than halfway through.
Supposed to do it using like regular kinematics. Like that's why like we're
How you guys
using.
doing? You have any questions?
I'm really try with momentum and see if I can actually get an
No,
answer.
no. Just let me know if you have any questions. How you guys doing? Okay, so do you have any initial thoughts?
So we can take the system as like the whole thing.
So you know it's E, right? So you
Okay.
know that it moves backwards.
And
Why does that happen? Why does that happen?
I don't know where to go from there.
Okay, right. So is
I know energy must be conserved throughout.
mhm.
And we start off with energy of 0 or something.
Okay, why?
It's not moving yet.
Mhm.
So that means A is moving this way. I guess it's releasing some of its potential energy for kinetic energy.
Right.
Here the ramp moves back in the same time.
Mhm.
I don't know where to go from there.
Okay, so what do you have written over here?
I currently just use the new control forces. Pretty much they're in contact with A, so it's going to force in the opposite direction. Because there's no friction to resist movement, this will really force on the X direction, hence it'll go this way.
Right. And you're trying to find a way to explain it using the conservation laws?
Yeah.
Okay, so knowing that the energy is conserved, right? Because there's no friction. And considering this block, these two blocks as a system, its initial energy would be which energies? What would its initial? Yeah, right. So initially, where's the energy going to be found? The initial energy.
Yeah. The only thing that would change
Is it? What do you guys
both
think?
initials together.
Oh, right.
Right. So all of the initial potential energy is going to be in block A because it's held at a certain height. But since block B isn't moving and it's already on the table, there's no energy in block B. But then what happens after you drop block A?
Well, it starts releasing that as kinetic energy. There's nowhere else to go.
Right. Yeah. Does that make sense? Yeah. Okay, cool.
It's like
So are we not going to use the momentum
you're like point down, like
You don't have to for this particular problem. Do you have any other ideas of how you
it
would
can't go through it,
prove it?
so it actually puts like more force.
someone else talking about using like or like just
Right.
and they're saying that since velocity squared, you
For this particular problem, you don't need to use the energy rules yet. You can, but I think it would be easier for you to think about it in terms of forces.
Okay.
So thinking with that in mind, what would you think about the forces of the blocks acting on each other?
They're in opposite directions.
Right. So then how would that affect the velocity of...
Oh, they're in opposite directions.
Right.
Okay, is that all we need to say?
Yeah.
Okay.
Does it make sense?
Yeah, that's what I was thinking. I just didn't know how to explain it with the conservation.
Okay, right.
Yeah.
So could you explain to me why VXA is greater than 0?
Because it's moving in the positive.
Yeah, that's so as long as you say all of that, then you're good. That's good reasoning.
Okay.
Mhm.
Okay, we're at like 10:50. Do you want to cut it or keep going?
Yeah, no.